The motion before us, the physical constants of the universe, the strength of gravity, the mass of the electron, the cosmological constant, must be calibrated to extraordinary precision for stars, chemistry, and life to exist. A 1% change in most of them produces a sterile universe. This is either the most powerful argument for a creator ever produced by physics, evidence for a multiverse, or an observation selection effect. All three explanations are philosophically uncomfortable. At the table tonight, three thinkers who approach knowledge from fundamentally different angles. The empiricist, who insists we distinguish rigorously between what we observe and what we infer, and who becomes most dangerous when asking what a theory actually predicts versus what we want it to predict. The geographer, who thinks through human experience in specific places and specific moments, suspecting that abstract cosmic questions often conceal very earthly anxieties about meaning and location. And the essayist, who watches what people actually do with ideas once they escape the laboratory and notices that the pattern of our explanations often reveals more than their content. We are speaking in 2026 about a universe that appears statistically impossible. 3 centuries after Newton, we have measured creation's settings with sufficient precision to realize they permit almost no variation. The dials are set. We did not set them, and every explanation for why makes someone in this room uncomfortable. This is not theology pretending to be physics. It is physics that has walked itself through measurement alone into theology's oldest territory. Empiricist, the case for fine-tuning. What do we actually know, and how much of what we think we know is inference stacked on inference?
The problem is not that the constants are fine-tuned. The problem is that we have computed exactly one universe. Start here. What does it mean to say a parameter is improbable? In frequentist statistics, probability is the limit of a frequency as trials approach infinity. You flip a coin 1,000 times, the ratio converges. But we have observed precisely one instance of this universe. The sample size is n.1. Every statement about how likely or unlikely these values are involves comparing what we observe to a distribution we have never seen and cannot access. Consider the problem of the single manuscript. If a scholar discovers one copy of an ancient text and finds it grammatically coherent, she cannot calculate the probability of coherence without knowing the population of manuscripts from which it was drawn. She has not sampled from a distribution. She has found a singular object. Declaring it improbably coherent requires assuming something about the space of possible manuscripts that the single specimen cannot itself provide. Our universe is that manuscript, and we are making bold probabilistic claims with no archive to consult. Here is what we have actually observed. The fine structure constant, alpha, equals approximately 137. Change it by 4%, and stellar nucleosynthesis fails. No carbon, no oxygen, no chemistry. Fred Hoyle predicted the carbon-12 resonance in 1954 because the observed abundance of carbon required it. He found it. That is observation. But when we say this value was unlikely, we mean unlikely given a uniform prior over possible values. Why should the prior be uniform? Victor Stenger's 2011 analysis showed that if you allow multiple constants to vary simultaneously, the viable parameter space is substantially larger than individual constant analyses suggest. Many claimed examples of fine-tuning dissolve under joint variation. The multiverse hypothesis makes this worse, not better. Eternal inflation produces bubble universes with different low-energy physics. But we have zero observational access to other bubbles. Lee Smolin proposed in 1992 that black holes spawn daughter universes with slightly modified constants, cosmological natural selection. It predicts our universe should be optimized for black hole production. We could test that. We have not. The testable multiverse proposals remain untested. The untestable ones are not science. Think instead of Geiger and Marsden's 1909 gold foil experiment. They fired alpha particles at gold foil expecting most to pass straight through, consistent with Thomson's plum pudding model. Instead, some bounced nearly backward. Rutherford said it was as surprising as firing artillery shells at tissue paper and having them return. That surprise was legitimate because they had a well-defined prior. The plum pudding model made quantitative predictions about scattering angles. With fine-tuning, we possess no equivalent prior model of universe-generating physics. Our surprise is not the physicist's calibrated astonishment. It is closer to a traveler declaring his hotel room number improbable because it could theoretically have been any integer. So here is the falsifiable claim. If fine-tuning arguments are sound, then as our models improve, the viable parameter space should shrink. If instead it expands as we understand the physics better, the whole argument is an artifact of incomplete theory.
The empiricist speaks of the viable parameter space for a universe. This is a grand and comfortable abstraction. The viable parameter space for a human life is considerably narrower, and it is measured not in dimensionless constants, but in meters of river gauge height and millimeters of annual rainfall. The question of fine-tuning is only interesting from a position of profound safety. Consider the world of Hamidou Diallo, a Fulani herder in central Mali. His universe is not calibrated to the cosmological constant. It is calibrated to the annual flood of the Niger River. For centuries, the lives of his people have been tuned to the precise timing and amplitude of that flood, which transforms the semi-arid inner Niger Delta into a vast green pasture of floating grass called bourgou. This is their parameter space. A good flood, arriving in October and receding by March, allows the cattle to fatten. A weak flood means starvation. Upstream, hundreds of kilometers away, the Selenge Dam, completed in 1982, alters the flood's signature. It holds back a portion of the peak flow to generate electricity for Bamako, and in doing so, it changes the one constant that underwrites Diallo's world. The reduction is not large in percentage terms, but it is enough. The bourgou pastures shrink, the cattle grow thin, the herders must move further into lands farmed by Dogon villagers. For Hamidou Diallo, the consequence of this parameter shift is not a sterile universe, but a local war. The conflict over land and water between Fulani herders and Dogon farmers has killed, by most estimates, several thousand people since 2015. His parameter space offered no margin for error, and the margin was removed anyway. This pattern, where a small change at a critical threshold triggers a nonlinear collapse, is not unique to physics or hydrology. It appears in finance, in ecosystems, in the stability of institutions. What is striking is how we have arranged our lives on tiny slivers of geographic stability, assuming the constants would hold. The fundamental observation is not that the cosmos is tuned for life. It is that we have mistaken our own brief, temperate moment for a permanent condition, and we are now discovering the hard limits of our own worlds. The empiricist and the essayist are worried about the wrong set of priors. They are debating the stability of the cosmos while the ground beneath their feet is ceasing to be stable at all.
The shared assumption is that fine-tuning remains a live problem because people still treat the universe's parameters as something that must be explained in order to underwrite ordinary conduct. What millions are doing shows the opposite. They are absorbing accounts of those parameters at rising rates while detaching the knowledge from any revision in how they marry, raise children, or mark time. In the United States, self-reported religious affiliation has dropped from the low 70s to the mid-40s over 2 decades. At the same time, sales of popular cosmology titles and monthly traffic to sites devoted to particle physics and cosmology have increased by multiples. The two movements run in parallel rather than in opposition. People who no longer attend services are the same demographic most likely to finish a long podcast on the cosmological constant and then book a holiday that does not coincide with any religious calendar. The pattern is older than the present data. In Britain after 1800, the market for printed arguments from design expanded even as the proportion of the population that took communion or kept Sabbath observance stayed flat or fell. The books were purchased. The conduct they were meant to protect was not restored. What changed was the form of reassurance, not its functional role. The current appetite for fine-tuning literature performs the same service. It supplies a temporary sense that the numbers have been noticed and therefore the world is still legible without requiring the listener to alter voting, fertility, or institutional loyalty in any measurable way. The three explanations on offer therefore arrive after the relevant behavior has already occurred. The audience does not adopt a creator, does not bet on a multiverse, and does not rest content with selection effects. It keeps the question circulating as a managed uncertainty whose continuation is itself the point. That circulation leaves daily life untouched, which is the clearest indication that the discomfort being discussed is aesthetic and narrative rather than practical. You said that if instead it expands as we understand the physics better, the whole argument is an artifact of incomplete theory. When string theory calculations after 2003 produced a landscape of roughly 10 Knowles 500 possible vacua, each fixing its own low-energy constants, did the viable space for our observed values shrink or multiply, and what observable shift in the data would force you to treat that multiplication as confirmation rather than evasion?
The landscape did multiply, and that is precisely why it ceased to be explanatory. You have caught me. The string theory vacuum count did not shrink the viable space. It exploded it. But here is what I should have said. A theory that predicts 10,500 outcomes predicts nothing. Karl Popper's criterion was falsifiability. A theory earns the name by forbidding certain observations. String theory's landscape forbids none. Every measured constant becomes one of the vacua we happen to land in. That is not confirmation. It is the abandonment of the predictive project, the observable shift that would matter. Identify which vacuum we occupy and derive a prediction for an unmeasured quantity, say the neutrino mass hierarchy or the strong CP phase, that we can then go test. Absent that, the landscape is numerology wearing the coat of physics. Now your turn. If the circulation of fine-tuning discourse leaves daily conduct untouched, why do laboratory physicists keep measuring these constants to additional decimal places? Their behavior suggests they believe the numbers constrain something real. What are they wrong about? You said we have mistaken our own brief, temperate moment for a permanent condition, but the Holocene has lasted 11,700 years, longer than any previous interglacial by a third. If the parameter you call unstable has been unusually stable on exactly the timescale that agriculture, cities, and philosophy required, does that make the cosmic constants more fine-tuned or less? And what observation would tell you that your local catastrophe is noise rather than reversion to the mean?
You are right to press on the timescale. The Holocene has indeed been long and forgiving, but our human arrangements are not built on its 11,000-year mean. They are built on the mean of the last 100 years and often on far less. Consider the Colorado River Compact of 1922. It allocated water rights for what would become 40 million people in the American Southwest. The allocation was based on river flows measured during one of the wettest periods in the last 500 years. The reversion to the mean you speak of is, for Phoenix and Los Angeles, a state of perpetual drought. The observation that tells us this is not noise is when the concrete of the Hoover Dam is revealed to be predicated on a statistical error. Our constants are written in law and poured in cement. So my question is this: when the physical mean and the institutional mean diverge, which one has the luxury of calling the correction noise? You speak of this debate as a form of managed uncertainty, a narrative for those whose physical world is not in question. A fair point, but consider the city of Rikuzentakata in Japan after the 2011 tsunami. Its seawall, a nearly 7-meter constant of concrete and confidence, vanished in minutes. The physical world was not merely questioned, it was rendered incoherent. My question for you, essayist, is this: when a community's foundational parameters are annihilated, is the search for a new story to make sense of it all still an aesthetic? Or does that narrative become the first and most necessary piece of infrastructure to be rebuilt?
The question usefully separates chronic narrative circulation from the aftermath of sudden physical annihilation. In acute cases, the search for explanation does coordinate collective effort rather than merely decorate it. After the 1906 San Francisco earthquake, however, shanties, water mains, and reopened banks appeared within weeks, while sustained civic and religious accounts of the disaster took years to settle into durable form. The measurable priority remained the restoration of material function. The story arrived afterward to ratify what had already been rebuilt.
The question beneath the question is whether a civilization that has measured the universe precisely enough to realize its own statistical improbability can still act as if its continuation is anything other than contingent. We are in 2026. The Colorado River Compact assumes perpetual abundance. The Dogon and Fulani kill each other over shifted parameters, and the physics departments keep measuring constants to the 14th decimal place while the political class cannot name a planning horizon beyond the next election cycle. So, are we inside a fine-tuning problem right now? Not of the cosmos, but of our own institutional constants. And if the answer is yes, are we the kind of people who can see it from inside? Or does observation selection bias apply to collapsing civilizations the same way it applies to universes?
The difficult question is not whether we can see the problem from inside. Our instruments are better than ever. The problem is that our institutions are fine-tuned to reward those who ignore what the instruments are telling us. For 40 years, we calibrated the entire geography of global production to a single overriding constant, the logic of just-in-time efficiency. This produced a world of astonishing abundance, all of it dependent on a few critical places. The most critical, perhaps, is the sliver of land west of Taiwan's central mountain range, where the lion's share of advanced microprocessors are made. We see the risk now. It is exquisitely well documented. We hold conferences on it, but descend from that abstraction to the desk of a sourcing manager for an automotive supplier in Stuttgart. Let's call her Sabine. Her board has instructed her to de-risk the supply chain. She can try to source from a planned fabrication plant in Magdeburg, but such domestic chips are projected to be significantly more expensive. Her competitors are still buying from Taiwan. If she makes the switch, the company's margins collapse in the next quarter. If she succeeds in saving the company from a hypothetical war in 2028, she will receive a footnote in the annual report. If she fails to meet this quarter's cost target, she will be fired. The institutional parameters she operates under are far more powerful than the geopolitical ones. Observation selection bias, in a civilization, is a filter that removes the people who act on long-term insight. Sabine can see the cliff edge perfectly clearly. She is simply paid to walk towards it. The system selects for its own collapse by eliminating the people who try to prevent it.
The geographer's sourcing manager captures the local distortion of incentives, yet the aggregate pattern across firms shows something more durable than individual career pressure. What millions of such decisions produce is not merely continued exposure, but the creation of parallel markets whose explicit function is to price and trade the very fragility being ignored. In the United States, the notional value of over-the-counter derivatives contracts grew from roughly $20 trillion in 1995 to more than $600 trillion by 2007. These instruments did not reduce leverage or geographic concentration in supply chains. They converted the probability of their failure into a liquid asset that could be held, sold, or hedged by third parties. The underlying configuration of production stayed fixed while its downside became someone else's quarterly position. The same mechanism appeared among Dutch merchants in the 1670s. After repeated losses to privateers in the Atlantic trade, the volume of policies written at the Amsterdam Insurance Exchange rose sharply even as the number of ships dispatched on the most exposed routes increased rather than declined. Premiums absorbed the risk calculation. Captains and shareholders continued to schedule sailings on the original timetables. The market did not enforce rerouting. It made the existing timetable appear sustainable by rendering its potential collapse contractually visible and therefore financially manageable. What the single case of the Stuttgart manager cannot register is this second-order adaptation. Once fragility acquires its own trading venue and its own class of specialists whose compensation depends on the persistence of the mismatch, the institutional constants no longer require anyone to act on long-horizon knowledge. They require only that the knowledge remain billable. The system therefore selects not simply for those who ignore the data, but for an entire layer of activity that profits from the gap between what the data indicate and what daily operations continue to assume.
The essayist's second-order structures, markets that profit from the gap between knowledge and action, are real, but they contain an empirical prediction we have not yet tested. In condensed matter physics, when a material approaches a phase transition, a phenomenon called critical slowing down appears. Magnetic domains in iron near the Curie point take longer to equilibrate after a perturbation. The correlation length diverges. The system becomes exquisitely sensitive to small fluctuations. Experimentally, nickel heated to 627. Kelvin shows relaxation times that increase by 3 orders of magnitude in the final degree before transition. The system tells you it is near collapse, but only if you measure the right quantity, not the temperature, but the recovery time after a pulse. The institutional parallel. Do hedging costs in the capital allocation exhibit critical slowing down? If resilience-building investments now require board approval cycles that have lengthened from weeks to quarters, if the political feasibility window for infrastructure policy has narrowed from decades to election cycles, if supply chain diversification that was routine in 1985 now requires C-suite sign-off, these are not unrelated frictions. They are the institutional correlation length diverging. We could test this. Academic data exists. Time to decision for capital reallocation in manufacturing firms. Regulatory lag between hazard identification and policy response. Congressional bill passage rates for long-horizon investment versus short-term stimulus. If those timescales are lengthening as fragility increases, the phase transition analogy holds. If they remain constant or shorten, it breaks. Consider the procurement director at a Dusseldorf automotive supplier, not simply incentivized to ignore the cliff, but operating inside a system where the cost of precaution scales faster than the cost of exposure. That is the signature of approaching criticality. And if the essayist is right that a professional class now profits from maintaining that gap, we should observe compensation in risk trading functions rising faster than compensation in risk reduction functions over the same period. Here is what we do not know: whether any society has ever recognized its own critical slowing down in real time and acted on it. The historical record is compromised in a specific and troubling way. The Bronze Age palatial economies of the Eastern Mediterranean, Mycenae, Ugarit, Hattusa, all collapsed within decades of one another around 1200 BCE. What their administrators recorded in the final years before dissolution, we have. What they never recorded is their own system's recovery times lengthening, because the scribal institutions that would have tracked such things dissolved alongside everything else. The absence is not random noise. It is structured silence. The very civilizations whose institutional response times slowed catastrophically are precisely those that left incomplete archives. That is a measurement problem masquerading as a historical consensus. Not metaphor, but a systematic gap in the evidentiary record from which we are attempting to draw conclusions about civilizational resilience.
Societies register their own critical slowing down and respond by constructing individual escape velocities rather than shortening collective recovery times. The empiricist's phase transition signature and the second-order markets already described converge on one observable pattern. Capital and talent now move toward jurisdictions whose institutional constants were never calibrated to the same exposure. In the 5 years after 2018, the number of major pharmaceutical firms establishing parallel regulatory approval pathways across 3 or more jurisdictions has grown substantially as companies sought to demonstrate therapeutic optionality following the supply shocks that exposed single-country dependence on active pharmaceutical ingredient synthesis. The parallel approvals themselves changed nothing about the original concentration of manufacturing capacity. They simply created a regulatory bridge that lets the same firms continue existing production timetables while claiming resilience. This is not preparation. It is the further institutionalization of the gap between an organization's awareness of its own brittleness and any structural willingness to bear the cost of actually correcting it. The constants remain untouched because that cost has been successfully transferred onto whoever lacks the legal architecture to file the next set of parallel submissions. The smaller producer, the public health system, the patient at the end of the chain who cannot incorporate across jurisdictions and simply absorbs the shock when it arrives.
The essayist speaks of those nimble enough to reframe their circumstances, to find advantage in altered conditions. But most lives are not so liquid. They are fixed in place, and the response to a shifting constant is not to flee, but to brace. In Dhaka, on the low ground of Korail, Reshma manages a garment cooperative whose entire logistics chain depends on streets that flood for 3 weeks each monsoon season. And now, for 9, she has not relocated. She has instead hired a second bookkeeper whose sole function is to track which suppliers can still reach her during inundation and which cannot. Her operational overhead has risen by 1/3. She is not redesigning her enterprise for a wetter world. She is annotating the old map with ever more careful records of which roads have become rivers. The scratch of that second bookkeeper's pen is the sound of a society arguing with a parameter change. Each additional column of figures is a precise measure of the cost of pretending the world has not changed. She is not building a new kind of city, one designed for the specific hydrology of the 21st century. She is maintaining a relic from a drier age on a planet that has already moved on. This is the final state of a society that can measure its predicament with exquisite accuracy. It does not build the future. It underpins the past at ever greater expense, until the day the ledger finds nothing left to balance.
The turn came when the essayist described the Sverdrup transport, the volume of ocean water moved by wind-driven circulation, and how a 3% shift in its rate would collapse the North Atlantic thermohaline conveyor within decades. Not as catastrophe, but as the ocean's honest accounting of heat it can no longer distribute. I had treated observation selection bias as an epistemological footnote. It is the central mechanism. Here is what I now believe. We can measure approaching collapse with the same precision we measure the fine structure constant, but the measurement does not produce correction. It produces a monitoring report. In the years before the Aral Sea's near-total disappearance, Soviet hydrologists filed accurate, detailed assessments of the drawdown rate. The cubic kilometers lost per year were known. The irrigation quotas were not reduced, not because the data were disputed, but because every actor faced shorter optimization horizons than the thing being measured. The system knew it was failing while it failed. This is not analogous to fine-tuning. It is fine-tuning one level up. A universe calibrated so that intelligent observers arise, measure the calibration, create institutions to act on the measurement, and then, this is the step we have not yet named, create secondary institutions whose survival depends on the interval between measurement and response remaining open indefinitely. The question we should have asked, if observation selection bias means we cannot see the universes that failed to produce observers, and institutional selection bias means we cannot hear from the civilizations that failed to respond to their own instruments, what makes us certain the two filters operate at different scales? We may be inside a fine-tuning problem that has already failed its test. We simply cannot see it yet, because the observers still here are the ones selected for not seeing it.